Ozone depletion is a big concern among environmentalists today. What is the cause of ozone depletion? Is there a danger that the ozone layer will be completely destroyed? To find answers to these questions, we need to understand the ozone cycle. Stratospheric ozone is naturally formed in a two-step chemical reaction. First, ultraviolet sunlight breaks apart one oxygen molecule, O2, to produce two oxygen atoms, 2O. Then, each oxygen atom combines with an oxygen molecule to produce an ozone molecule, O3. These reactions occur continually in the stratosphere. So what is depleting this ozone?
Some of the ozone is depleted by natural sources. However, to a large extent, human beings and human-made causes are responsible for ozone depletion in the atmosphere.
But how? Many human activities involve the emission of halogen source gases that bring chlorine and bromine atoms to the stratosphere. These gases are also called ozone-depleting substances, ODS. Some important ODSs are the ones that contain only carbon, chlorine, and fluorine. These gases are referred to as chlorofluorocarbons or CFCs. Do you know of any such activities that result in the emission of CFCs?
CFCs and other ozone-depleting substances are used in refrigeration, air conditioning, foam blowing, aerosol propellants, cleaning of metals and electronic components, agricultural fumigation, and in some fire extinguishers. Some of the chlorine and bromine in the atmosphere come from natural sources such as oceanic and terrestrial ecosystems.
The emission of CFCs and other ODSs is the first step in the process of ozone depletion.
In the second step, these emissions are mixed in the troposphere and evenly distributed by the winds.
How long do you think it takes the CFCs to reach the ozone layer? It can take several years. CFCs are extremely stable. They do not break down or dissolve in rain. Eventually, they reach the stratosphere.
Here, strong UV light breaks apart each CFC molecule to release free chlorine atoms.
This is step 3 in the process of ozone depletion. In the final step, these atoms combine with atoms of oxygen, making it unavailable for the formation of ozone. Thus, they lead to a slow destruction of ozone. One chlorine atom can destroy over 100,000 ozone molecules before it is removed from the stratosphere. Do you know where the impact of ozone depletion can be observed most clearly and easily? Place where ozone depletion can be observed most easily is in the atmosphere over Antarctica. The ozone hole is a severe depletion of the ozone layer there, high above Antarctica. The size of this hole has increased since its discovery. However, the size of the hole shows seasonal variations.
The size of this ozone increases during August to October.
As temperatures rise and the air becomes warmer, the ozone layer stabilizes again.
Large increases in stratospheric chlorine and bromine indicates that ozone is getting depleted at a faster rate than it is being formed.
Therefore, ozone levels have been falling over the last few decades. This is dangerous. A thinner ozone layer means an increase in the amount of UV radiation that reaches the surface of the Earth. Ultraviolet rays are high-energy rays that can cause changes in the chemical structure of molecules. Such changes can lead to transformation or mutation of hereditary information in living beings.
Result: deformities and diseases such as skin cancer, cataracts, and respiratory disorders.
Other impacts of UV radiation include damage to crops and to marine phytoplankton. You may be aware that phytoplankton forms the base for most food chains on the planet. Therefore, an increase in UV radiations can lead to disturbance in most food chains as well. What steps can be taken to prevent further ozone depletion? The first step in this direction was the Montreal Protocol on substances that deplete the ozone layer.
Under this protocol, many countries signed agreement to protect the ozone layer by phasing out the production of ozone-depleting substances.
Some other measures that can help protect the ozone layer are
use of safer alternatives to CFCs, regulation over large-scale use of ozone-depleting substances.
Apart from these measures, here are some do's for all of us. Use products which are labeled ozone-friendly. Ensure technicians repairing your refrigerator or air conditioner recover and recycle the old CFCs so that they are not released into the atmosphere. Check vehicle air conditioning units regularly for leaks. Replace halon fire extinguishers with alternatives such as carbon dioxide. Try to initiate activities that increase awareness of the problem.